Hello, everyone. Welcome back to SAT Math Question of the Day. Here's our question of the day. It comes from the educator site of SAT. This question, a spoiler alert. This may be on a Blue Book test. Spoiler alert. Alan drives an average of 100 miles each week. His car can travel an average of 25 miles per gallon of gasoline. Alan would like to reduce his weekly expenditure on gasoline by $5. Assuming gasoline costs $4 a gallon, which equation can Alan use to determine how many fewer average miles M he should drive each week? So it's a little bit confusing. It's certainly not the run-of-the-mill word problem. So maybe that's why they give it a difficulty level of the highest difficulty level possible. So let's see. You want the units to be in miles. So miles is going to be the final unit, and you got all sorts of combinations here. So when we do the analysis, when we do the work, we have to make sure we end up with units of miles using some dimensional analysis. Alan drives, now we have to reread. Alan drives 100 miles a week. His car can average 25 miles per gallon of gasoline. He drives 100 miles a week. Okay. Alan would like to reduce his weekly expenditure by $5. Assuming gas costs $4 per gallon, which equation can Alan use to determine how many fewer miles M? Oh, he wants to reduce his gas by $5.
Yeah.
So that means that these are probably going to be the answers, because he wants to know which equation can he use to figure this out. So he wants to have the dollars. Oh, I'm wrong. The 5 has to be in units of dollars. Sorry about that. 5 has to be in units of dollars. So when we do this math, we have to make sure that the units of 4 divided by the units of 25 times M are dollars. So M are miles. And then the 4, well, this one, the 4 is in dollars, and 25. Oh, wow, so that's good. This is 25 miles, so those cancel out. This is probably not the right way to do it. This is so not the right way to do it. But, no, this means the units work. In this one, the 25 is miles. What am I? Oh, I'm really messing this up. I am so messing this up.
Well, first of all, 25 is not miles.
Yeah, 25
miles
is not miles.
Per gallon.
Right. So, in other words,
and 4 is not dollars or gallons. It's dollars per gallon.
That's right. That's dollars per gallon. And
25, so you do units. Get your units. Get your units right. Don't
25.
Cut them short to make them wrong.
No. You're right. No, I caught my own mistake. 4 is in dollars per gallon. 25 is in miles per gallon. These cross out to be 4 over 25 dollars per mile, and we know that the M is in miles. So we have 4 over 25 in units, dollars per mile, times 5 miles gives you dollars, which is what this unit should be in. So this would not be right. So it looks like it's D, but this is so not the way to do the problem. I feel like this is the wrong way of doing it. You're not really thinking about the problem or anything. Do you have a better way of doing it? I probably do too.
Okay.
If I spent more time on it, but
so what they want is.
I mean,
first of all, first. Look, you got again. What do they ask? The question is asking for which equation. It's not asking for M.
That's right.
Okay,
right.
But one approach is to guess. Is to figure out the interpretations of the given equations. Another approach is to find M and then pick the equation that corresponds to the calculation for finding M.
Hmm.
So my feeling is to first try to see what's happening with M.
Okay.
So because the equation is used to determine M. So let's see what we have to do to determine M. So let's think of this. So suppose he drives M fewer miles.
Yeah.
He wants to spend $5 fewer.
$5 fewer, right.
So what we're going to do is convert the miles that he's saving into the dollars that he's saving. So we're interested in something that you multiply by M to convert from miles to dollars.
Right.
Now, what's given? You're given the rate of miles per gallon is 25. So if we divide M by 25 miles per gallon, we get gallons. So if he saves M, he drives 5 fewer miles, he will use M divided by 25 fewer gallons. But his goal is to save dollars. So this is the amount of gallons he would save. We want to convert that to dollars. Well, the price of the gasoline is $4 per gallon. So if we multiply this by 4, we convert it to the amount, the number of dollars saved.
Yep.
And we want the number of dollars saved to equal 5. Analyzing what he wants, what he wants leads you to an equation for M. And it matches this equation.
Right.
Okay?
So this is
notice this is one of these problems where they confuse you by giving you unneeded, unnecessary data. Now, see, it doesn't matter how many miles per week.
Right.
All he wants is for whatever he's spending. He wants to spend $5 fewer.
Right.
Okay, so the $100 doesn't matter. So we want to convert. So the equation is one that converts M for the number of fewer miles into the number of fewer dollars. Right. So then we use the data that converts from miles used to dollars spent for the gasoline to power the car to drive those miles.
There's a lot to digest in this. There is. You really have to think about it a bit. If this was a test, if this was a question later on the test, I don't know about you. I needed more time. So if this is a question later on the test, it would probably be very nerve-wracking because you really have to sit here and think about this. It's certainly not the clearest word problem, especially the way it's worded.
Yeah, it's Yeah, it's not asking you to solve for M, figure out what M should be. It's a problem of figuring out an equation whose solution is M.
Right.
So so a different approach is try to get M directly.
Yeah. Yeah.
So the way to do that, to get M directly, here's the approach. You start with, he wants to save $5, right? So if he's going to save $5, how many gallons does he have to use less? How many gallons does he have to save? So he convert the dollars into the gallons of gasoline using the price of the gasoline. The price of the gasoline is $4 per gallon. So you divide 5 by 4. He needs to save that many gallons. Now, for that number of gallons, how many miles is it? Well, he's getting 25 miles per gallon. So you take that number of gallons, 5 divided by 4, and multiply by 25 to get the number of miles that he needs to drive
5 by
fewer.
4. Wait, what did you say? What did you say?
Okay, you want to save $5.
You want to save $5, right?
So, how many fewer gallons should you use?
Right. Or
how many gallons does it take to go 5 miles?
Exactly. If you only have $5 in your pocket, how far can you drive? That's another way to think about it. Yeah, if you
That's
only
another
have,
way. Yeah.
If you only
so
have
you get so you get that by
how far can you drive?
You get that by here's the 5 divided by 4, and this gives you the number of gallons that are saved when you drive 5 fewer miles. But you're interested in saving. You're interested in saving dollars, so you want to convert gallons to dollars, and so it's no. So you want to save $5, convert it to gallons. But he's interested in the number of miles to save, so he needs to convert gallons to miles, right? And for each gallon, you can go 25 miles.
Yeah.
So for this number of gallons, a little bit more than a gallon, you're going to that corresponds to driving this fraction, which is, 1 and 1.25 gallons. Multiply it by the number of miles that his car on the average gets per gallon. That gives you the number of miles.
Yeah. I mean, if you rewrite the word problem like this, it's a little bit easier to at least understand what you have to know. How far can you drive if you only have $5? So, yeah, if you only have $5, then you need to multiply the $5 by your miles. By your miles per dollar. Right?
Yeah.
And that'll give you how many miles you can drive for $5. So you need this ratio, miles per dollar. And that would be miles per gallon divided by dollars per gallon, right? So this is $5 multiplied by mile. Oh, right, I need her. How far can you drive if you have $5? So you have $5. You need to multiply that by how many miles you go per dollar. So miles per dollar. This is the key to the problem. So I guess a little bit of you could see that the miles per gallon and the dollars per gallon. And they give those to you, right? Miles per gallon is 25 and dollars per gallon is 4. So that's it. That's how far you could drive. M is $5 times 25 divided by 4. M is 5 times 25 divided by 4. And M is 5 times 25 divided by 4.
Yeah.
Yeah. Notice the...
So it's posed this way. The strategy that leads to this equation is to write the equation for what he wants. And what he wants is the value in the equation is some expression in term of the unknown equals what he wants. What he wants is $5 of savings.
Yeah. Right. Well, no. Yeah.
So
right.
we want to convert miles that his car gets on the average, together with using the data about the price of the gasoline per gallon, convert miles that his car might drive or would not drive, to convert to dollars, which is what he wants to save. And then you say this function of the number of miles equals 5. And that gives the equation. The left-hand side has the unknown M.
Yeah.
That's what the problem's asking for.
So, I mean, we're all probably confusing everyone, including ourselves. There are multiple ways to view this. I like to sort of, make the words simple so I can really understand what's going on, because I get confused by this. But I sort of like the idea of sort of thinking about it first and realizing the question really comes down to how far can you drive if you have $5. And that's an intuitive question, because you may only have $5 in your pocket. How many dollars can you drive? You can certainly understand what's being asked here. Here, what's being asked is a little confusing. So maybe one thing to do in a confusing word problem is recast it into a problem that sounds like it's less confusing, and then proceed. And that's the way I like to. I dealt with this thing, this monster.
Well, the way I dealt with it was that I realized that calculation of savings of different calculations of saving of different quantities are the same as calculation of losing or using up certain quantities.
Right. Yeah.
The formulas, the relationships are exactly the same for what you save by not purchasing something, in terms of what you spend by purchasing something. Exactly the same thing, the same numbers.
Yeah. I mean, but there's a lot going on in this problem. I also found the analysis using dimensions here. When I did it down here, it was messy. But here it's more clear. If you want to know how far you can drive $5, you have to do $5 times the miles per dollar, which makes sense to figure out how many miles you drive. So then the problem really comes down to getting this ratio. And this ratio, they don't give you this ratio. They don't give you miles per dollar.
Yeah.
So
okay. Well, again, I think without thinking, you could solve this problem, given that they give you the formulas.
That's true.
And that they're all the formulas are the same, use the same kinds of operations.
Yeah.
You could identify the dimensions for the 3 numbers.
That's right. Yeah.
Actually, you need 4 dimensions. You need the dimensions for the 4 quantities, 3 numbers, 3 numbers and 1 variable. And then you pick the equations whose dimensions are consistent.
That's what I did at the very beginning, Seth.
Yeah, which is what you did at the very beginning, except that you said M.
I know, I made a mistake.
Except that
I know.
Except that you said four.
I know, Seth. I know I made a
Yeah.
mistake, but
You
then
have
I
to get,
realized.
if you're going to do it that way, the dimensions, if you're going to dimensionally analyze, you have to work with accurate
Well,
dimensions.
obviously that's true. You don't have to repeat it.
Yeah.
Of course it's true, but I caught it. I caught it. I caught it. I realized there
Yeah.
was a mistake, and I corrected it. Yes, the other way to do it is just by looking at the choices. This is one of those, and this is one of these questions. Is that a metal straw, Seth? That's cool. That's cool. That's cool. Okay. But this is certainly one of these questions which one can solve by going through the choices and just testing each one, using which ones the dimensions work. These the dimensions don't work, but these they do. But then you realize the 95 is not the right number you would be solving for. Because 95 is in the units of miles, because it's 100 minus 5. Wait, there's not even a 5 here.
Yeah.
Wait, where's there a 5? There's a $5.
On the right-hand side, yeah.
There's a $5, but dollars and miles are not consistent. So where's the 95 can't be part of the problem. Because if in order to get 95, you do 100 minus 5, but 100 is in miles and 5 is in dollars. So that you don't, then you can cross this one out, because 95 doesn't even make sense in the problem here. So this is the only one with consistent dimensions. Right. Yeah, you have to do that. You have to know how to divide fractions in order to do that. You have to know.
I would agree that this is a difficult problem.
I would agree too, yeah. Well, also there are many ways to solve it. Everyone's going to do it differently. So why don't we see how they do it? Okay. Well, let's say the big reveal. Okay, here we go. So we trash everything, all of our drawings. And go like this, and here we go. Oops. I'm just gonna have to move us for a second, so excuse us. Okay, put us back, and here we go. So I'm gonna have to go small. Okay, so that's fine. Okay, choice D is correct. Since gasoline costs $4 a gallon, see, they're not planning it out. I wish they. That's the problem. You got to plan these things out. They're just blasting right in as if they know how to do it. Well, since gasoline costs $4 a gallon, since Alan's car travels 25 miles a gallon, the expression 4/25 gives the cost in miles per gallon. Okay, so let's do a little bit of annotating. So this is dollars per gallon to drive the car. Multiplying 425 by M miles. Wait. That's wrong. It's dollars per mile. Okay, multiplying by miles gives the cost in dollars, which is M miles gives the cost for Alan to drive his car M miles. So 4/25M is his cost in dollars. Okay.
Yeah, so,
but he wants. Oh, I see. He just wants that to be equal 5.
Yeah.
So they did it nicely.
In the explanation, cost is $5.
Right. Yeah. So that's a nice, clean way of doing it. But the problem, the thing is, they knew how to. The person who wrote this already solved it, which is not what all of us do when we take questions cold. We don't know how to solve it, so we can't organize. You can only write this if you know what to do.
So they really should say, they should say is he wants to save $5, and the problem asks for an equation of the form f of m equals 5. That's what, is he so.
Right. Okay. Yeah. F.
Except they're not talking about, they didn't use function notation.
What is
Yeah.
f of m? Yeah.
What's his f? What is f of m?
Right.
And then, yeah.
Yeah, see, it's right. The way we all do the problem is we do it backwards. We think about what we have to write in order to get 5 miles, in order to get this, as opposed to just writing it out forward-wise. Always a problem with
5 is dollars.
Fives and dollars, right? Yeah. Too many units here.
Keep yourself awake.
There are a lot of units here. Yeah. So, again, if this question was late in the test, then your brain is a little fried, because this would be the later question after you've taken both Englishes, the first module in math, and if you're lucky enough to get into the second, or unlucky enough to get into this harder module in math. If this came at the end, your brain is completely fried, and good luck. But, again, try to recast it in a simpler way of doing things. And dimensional analysis is so useful. The acid test for your answer is the dimensional analysis. If the dimensional analysis is wrong, then your answer is wrong. And if the dimensional analysis is right, then it's more likely your answer is wrong. It's more likely your answer is right. Okay, so what are the main ideas here? What are the 5 questions you always ask? Calculator, absolutely not. Calculator has absolutely nothing to do with this problem. Can you start with the answers? Absolutely. You absolutely can start with the answers and just figure out which one works. How is this different from a school test? Teachers aren't going to give a question that's this convoluted. They wouldn't give any.
Some might.
This really sounds like a question from on a college test, a college board test, or an ACT maybe, if you're unlucky on the ACT. Okay, and then the big question is, patterns. Are there patterns? Is there anything specific to the numbers in this question that allow you to do it faster? I would say no. There are no patterns to this. And then the big question at the end, most important question, is what is the main idea? What are they? What was the intention of the College Board Committee when they wrote this question? What did they intend to test to see if you knew how to do? I guess just how to deal with word problems and ratios. I know that's very vague.
Yeah, rates and ratios.
Word problems.
A word problem with rates and ratios. With basically that 4 different ratios.
Yeah, I was going to say multiple ratios. Word problems with multiple ratios. And when you're
many ratios.
When you're dealing with any problem with multiple ratios, dimensional analysis is the acid test. That is a great way just to keep all these ratios straight. Do you agree, Seth?
As long as you actually work with the correct ratios and not simplify it in your brain.
I didn't simplify it, Seth. You gave me too much credit. I didn't even simplify it with my brain.
No, that's totally simplified. Miles per gallon.
Yeah.
Right? It's very tempting to just say miles.
Yeah, I know.
But when you need to pay attention to mathematical types of issues, thinking of miles per gallon as miles is too simple.
No, I didn't even, Seth, you're giving me too much credit. I didn't even think that way. I just totally got it wrong.
Yeah.
I wasn't even thinking of simplifying it. I just completely
the thing is, just when the care you need to take when you deal with rates is that if you have a rate like miles per gallon, it stands for miles divided by gallons.
Absolutely.
It is not miles.
We know that. You have to...
I think your mistake was that you said miles when you meant miles per gallon.
No, I didn't even mean miles per gallon because I didn't even read the question right. You're giving me too much credit. Stop giving me all this credit. I totally made a mistake. You have to be really careful with dimensions.
Okay, all right.
And you also have to write big. I mean... no excuse for the way we're writing. I'm writing on a tablet or on a computer. It's not as if I'm writing on paper, which is healthier. Of course, make sure you get scrap paper and use it on the SAT. Got to be really careful when you do dimensional analysis. You got to make sure the dimensions are right. Obviously, of course. Okay, so I think we're done, right? We're more than done. We are cooked on this one. So, okay, everyone. I hope you got something out of our discussions. I'm Joel. I have a PhD. Sort of like can't see my thing. I have a PhD in mechanical engineering, and my brother Seth is a PhD in math, and we are here to hopefully show you how to approach the SAT math questions. We come from different backgrounds and different educational backgrounds, and we look at the problems different ways. And we hope that by just going over things, and we'll even offer alternate approaches to the ones we originally thought of doing. And hopefully we give you some insight as to these questions. What you need to do is practice as much as possible, do all the Blue Book tests. We've heard rumors that Blue Book 4 and 6 are closest to the actual digital SAT, at least on the math side, so take those tests very seriously. Those are probably your best diagnostics for what you can expect on the actual SAT, at least as of now. If you have any SAT math questions, please email them to us at satmathquestionoftheday@gmail.com. And I guess I feel like I forgot something, but oh yeah. If you're doing the SAT questions and you realize there's some topic that you're a little bit weak on, go to the Khan Academy digital SAT course. They partner with the College Board, and they have a lot of questions on each topic, so you could bone up on a specific topic you're a little bit weak on. So that really is it, I think. Okay, everyone, have a great day. Hopefully see you tomorrow.